All right, here we go. First lesson of the new marking period. Isn't that exciting? And we're already one lesson in. So remember, this is a little bit of a shorter marking period than normal. So let's make sure everything gets done. I don't usually have to tell you guys that kind of stuff. I gave big speech to my CP classes, so I won't give it to you. All right, tangents. We're still dealing with circles. The whole chapter is about circles. Gabby. Who's got a colored pen? Sure. She wants to give you a colored pen. You can use a colored pen. All right, so we've actually talked about this, a tangent. You remember? You will once I start doing it. You know how sometimes I might tell a story and then I go off in a different direction than I intended? Sometimes they say that is going off on a tangent. Actually, let's make this a little smaller. Easier. Yes. Well, it just doesn't keep going. There's a lot of things that keep going, but this one is basically this. There's a lot of chatter. Maybe I'll have to put you all in the front row. All right, here we go. So a tangent is a line. Okay, it could be a line segment as well. Everybody settled? Mentally settled? All right, so it's a line, or it could be a line segment as well. But most of the time they talk about a tangent being a line. And what does it do? Does it go like that? No. What do we call this, by the way? When it goes through the circle, a line that goes through the circle. It's a line, which means it keeps on going. Do you remember? It's called a secant. That's right. So we did talk about that. And then what's the difference? Oops. Let me bring that back up again. There we go. Okay. What's the difference between a tangent and a secant? A secant goes like this and it hits a circle in 2 points. What does a tangent do? Why do I keep doing that? It hits it at what? 1 point. Not spot. Let's be specific. It's geometry. It's a point. It hits at a point. So there is a point right there. And it only hits one. Now, like if I enlarged it, it would look like it hits at a lot of different spots. But remember, lines and circles, they don't have any width. All right? There's no thickness. There's no width to it. But we can't really draw something with no width, and you wouldn't be able to see it, would you? All right. So this is a representation of a line, okay, and a circle. And this is a point. Again, it's a representation of a point because a point doesn't have any width. If I really, really zoomed into that point, you would see that it does have some width. All right? I don't think it has any depth because it is digital. It's not a mark. But if I mark on this board right here, this does have a little bit of thickness to it. It's got some height to it. Not much, but it's got a little bit. But anyway, this is a point. This is a line. This is a circle. And this is a tangent. All right, so a tangent is a line that intersects a circle at 1 point. Everybody got it? All right. Swanky, you getting all this? You doing double duty? Reading a book and then watching my geometry? This thing right here, this point, has a special name. We call it the point. Oops, spell it right. We call it the point of tangency. All right. So the point where that line hits the circle, remember, it only hits at 1 point. So that 1 point is called the point of tangency. We're going to learn some more about it. But right now, I'm just giving you some foundational stuff, just some words, some definitions of what these things are. We might as well talk about this as well. What did I say I call this thing right here? That's a chord. A chord is a line segment. A chord has endpoints on the circle. This doesn't have endpoints on a circle. It's a secant, right? We said it earlier, just a few minutes ago. Whoops. I'm having real trouble with my pen today. Seems like every day I say that, so maybe every day I have trouble with it. So that's a secant, right? What's a secant do? It hits the circle how many points? At 2 points, okay? But we're going to concentrate on tangents today, I believe. Let me see. Yes, today is all about tangents. We will talk about secants in another lesson. Not sure which one it is, but anyway, I just want to show you the difference between a secant and a tangent. All right? Pretty simple so far, isn't it? Yeah. But there are, you could also define a tangent to be a line segment. So like if this thing started right here and it ended right there, that would still be considered a tangent, but it would be a tangent segment, okay? You with me on that? So even if it doesn't keep on going in both directions, if it started here and stopped here, it could still be tangent to the circle as long as it only hits the circle at one point, okay? So they would call that a tangent segment. Let me see if there's anything else. Yeah, that's good enough for right now. Let's go right to the next theorem then. So let me copy this circle. So I'll have to draw it every single time. There's a circle, and I'm going to put the center in here. That's important for this one. All right, so here's a theorem. Tell you what, I'm not going to write out the whole theorem. It's a little lengthy. I'm going to read it to you, and then we're just going to show it on the picture what it does, okay? So it says, if a line is tangent to a circle, all right, so picture there's a tangent. In fact, let's just draw it while I'm saying it. All right, so if I had a line that's tangent to the circle, so here's a line, and boom, right there, it's tangent to the circle. Agreed? I'll do it now, but I'm not necessarily always going to put arrows at the end of these, but just, again, think of them as lines just because of the time it takes. So if a line is tangent to a circle, do I have that in this situation? Yeah. All right, there's the point of tangency, okay? The theorem says this. If you have this situation, if you got a tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Do you hear what I just said? I'll read it again. Then, if I have this situation right here, then it is what is it? The tangent line, okay, is perpendicular to a radius, okay, drawn to the point of tangency. So all those are important. So I could draw a radius. Where would I have to start if I'm going to draw a radius? From the, what point? No. Where am I going to start? From the center of the circle, okay? Now look, there's a radius. Is that radius perpendicular to that tangent line? No, why not? Because that radius is not drawn to the what? To the point of tangency. So if I drew that to there, okay, what kind of angle did I just form? What does the thing say? It is perpendicular to the radius at the point of tangency. So this red one and this blue one make a what kind of an angle? A right angle, because they're perpendicular. I could draw another point of tangent. It doesn't have to be like horizontal looking like this. Okay, that wasn't exactly horizontal, but I could just do some random tangent like this. Everybody see that? All right, so there's a tangent, hits right there. So what is that point? This is the point of tangency. And so what does the theorem say? It says if I take a radius to the point of tangency, what kind of angle did I just form? A 90-degree angle. You see that? So it doesn't matter which direction your tangent's going. It doesn't have to be just across the bottom. All right? It doesn't have to be horizontal. Okay? It could be going all kinds of directions. So if I have a tangent going like this, it's always perpendicular to the radius drawn to that point of tangency. We okay? All right, it's pretty basic, isn't it? Yeah, so if I have a tangent and then I take a line from the center and I draw it to the point of tangency, it's always going to be a right angle because they're perpendicular. I could do more if I wanted to. I'm not going to. All right? What if you had this? What if you didn't know the blue line was a point of tangent or a tangent line? Okay? But you did know that this line segment, this radius, is perpendicular. So what if you knew that this was perpendicular? Then what could you say about that blue line? Then it's a what? Then it's a tangent line. That's right. Okay? That's the converse of what we said earlier. All right? It goes both ways. So The first part of the theorem said, if I know that that's a tangent, then what's true about that angle? It's a right angle because it's perpendicular. The converse of that says, if this radius is perpendicular to that line right there, then this is a what? A tangent. Okay? See the difference? It's kind of the same, but it's a little different. All right, that's enough to do an example. So let's do an example. There's a circle. Let's do this. Let's change colors. Let's use this pink color. I haven't used that too much. All right, watch this. I'm going to draw a tangent here. Okay. And then I'm going to draw a tangent here where it just hits. Okay. Let's draw the point of tangency. That one's probably going to be right there. This one's probably going to be about right there. All right. And watch what I'm going to do. Well, I need a center, don't I? Let's draw the center first. Oops. Right there. All right, there's the center. That's a little better. Now, check this out. I am going to draw a radius to that point of tangency. I draw another radius to the other point of tangency. So right now, if you knew those two pink ones were tangents and you knew that the yellow ones were a radius, what can I say about this angle? It's a right angle. It's 90 degrees. Yep. Okay. And this right here is a right angle. So that's really going to help you. All right. And then here's what they do. They tell you that this angle right here, that looks like a 90. It's not, doesn't necessarily have to be. All right. We'll call that 3x and we'll call this one x. And we'll call this, let's scooch it up a little bit. Come on, there you go. We'll call this ABCD. So this is A, call that B, call that C, we'll call that D. All right, there you go. So that's everything they give you. Everybody got that? And you just have to solve for all four angles. So solve for angle A, find angle B, find angle C, and find angle D. So what do we do? Say what? Plug into what? Well, B and D is 90. That's pretty easy right now, isn't it? All right, so I could just say that's 90. Oops. That's 90 degrees, and this is 90 degrees. So that was easy. We're halfway done. Now I just have to find A and C. So how in the world do I find A and C? Oh, you're just looking at the example. Come on, look up here and think about it. Everybody should be able to do this. You don't really, our knowledge of tangents ended right there. Okay, that's all we had to know is that that's a right angle and that's a right angle. That's really the only thing we had to know about the tangent for this problem. Samantha? 360, say it again. Okay, so we could do that. What do all four of these angles add up to be? 360. So let's do this. I'll do it. And what you said was fine. Okay, you could actually do it a little bit more efficiently than that. But I'm going to show you all the work. Okay, so x plus 3x plus what? Yeah, 90 and 90, right, which is 180, equals what? 360. Now you know this is going to be 180. What's 360 minus 180? It's just 180. So what do these two do? They just add up to be what? 180. So you could have done that in your head, and that would have been fine. So if it was me, I probably would have gone this. I probably would have gone x plus 3x equals 180. You understand why? Because these two, 90 and 90 is 180. Take it away from 360, that's a 180. So these two add up to 180. So let's do it. 4x equals 180. Divide both sides by 4. What's that? 45. So x is 45 degrees. How does that help me? Plug it in. That's right. So let's plug it into this one. This would be the easiest one. That's just x, right? We found what x is, 45. Actually, this technically is not degrees right here. It's just 45, okay? But because, yeah, I just put these numbers in. I mean, you could put a degree, but I think I'd feel better if you didn't. But if you go up here, angle A, it's x, which is 45. It is an angle, so now we can put the degrees there, okay? What about C? What do we do with C? That's it. Just times it by 3. Can you do 3 times 45 in your head? What's 2 times 45? Add 90 to another 45. 135, right? Because I think of this. If I think of, what was I thinking? 2 times, 90. Okay, so the 90 plus the 45. So 90 is close to 100, right? I know what 100 plus 45 is, but I got to take 10 away because it's really not 100, it's 90. And so it's 135. Anyway, however you do it, that's what you should get. Pretty simple, isn't it? Yeah, what's the only thing you really had to know about tangents on this? That these are 90 degrees, that's it. Okay? That's all you had to know. Then the rest is just stuff we've been doing all year, haven't we? Add stuff up, set it equal to something, or we set things equal to each other, then you solve for x and you plug it back in. How many times have we done that? All year long, haven't we? Yep. All right, let's learn some other stuff. I'm going to make this a little bit smaller for what I'm going to do here. All right, check this out. I'm going to put a point out here. Everybody see this? See that point right there? Let's make it into a different color. Like red. All right, check this out. I'm going to start at this point. I'm going to draw 2 tangents to that circle. Can I draw any more than 2 tangents to that circle? I can. Well, let's draw one of them. It would be from here to until bang, right there. It hits right there. Everybody see it? So that's one tangent. How could I draw another tangent? Yeah, down here like this. Okay? Until it hits, boom, right there. Looks like it hits, doesn't it? Can I draw another tangent from that point? From this point? No. All right, because if I did, well, I couldn't, but the only way I could do it, up here it's not going to touch the circle at all, right? But if I go below here, what does that become now? What is that thing? It's not a tangent, it's a secant. That's right. Secant, 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 all the way until you get to here, and then it's a tangent. Can you draw any more than the 2? Not from that one point, you can't. Okay? From that one point, you can just draw 2 tangents. What I'm going to do is this. I am going to, remember, a tangent technically is a line, but I'm going to stop it right at the point of tangency. Is that all right? Then I'm going to take this one, do the same thing. It still only hits that circle at that one point. Yes? All right? So this is just a tangent segment. Remember, we talked about that earlier. This is a tangent segment. So what do you think is possibly true? We'll call that A, we'll call that B, and we'll call that X. Just by looking at it, what's your gut feeling on this? They're congruent to each other, exactly right. And that's what the theorem says. It's true that they are congruent to each other. So I could put a little tick mark here. Or I could say that the length of line segment AX is equal to the length of line segment BX. Would you agree? That's what this theorem tells us. All right? If you have 2 tangent segments drawn from one point, one particular point, those tangent segments are equal to each other. Guy, would you have your hand up? Yeah, tangent segments. And they call this an exterior point, obviously, because it's what? It's outside, right? It's outside the circle. So that's an exterior point. So I'm going to read off the theorem exactly the way they have it. It says tangent segments from an exterior point to a circle are congruent. Would you agree with that, according to this picture? Yeah. Okay. Well, that was kind of easy. We're going to use that in this example. Another example. They tell you one little thing, and then you throw an example in there. Here's another circle. Get a little smaller, just so I can fit some stuff in. All right, now check this out. I am going to, let's do a different color this time. Let's go blue. Look, there's a point right there. We'll put a point right here. We'll put a point out here. And we'll put another point about right there. Well, you know what? I can't do that yet. Sorry. Let's just do one at a time. I was a little ambitious. All right, I'm going to have to draw it a little bit nicer. So watch, I'm going to draw a tangent to here. But what I'm going to, yeah, let's do that. I'm going to just draw a tangent to there. I'm going to draw another tangent to there. Well, not to there, but I'm going to draw another tangent, like out here like this. Everybody with me? Then I'm going to draw another tangent like this. And then I'll try to clean this one up a little bit. This one goes a little bit too long. I'll just go up to there. Look at that. That looks kind of cool, doesn't it? Yeah. So where are my pointed tangencies? One's right there. What's that? Oh, yeah, it is a quadrilateral, isn't it? Thanks for that. Sorry. Yeah, I didn't draw these too well. Let's try this again. How I didn't see that, I don't know. Maybe because I had that a little too far out. So let's try this. Let's go out like this. And let's go like this. I think I'll do it right this time. Then it's going to go like that. And then one more. There we go. Doesn't look exactly like what the book looks like, but it's pretty close. All right, that's a quadrilateral. Good enough. So where are the pointed tangencies? There's one here, there's one here, here, and here. Okay? And we'll call this thing PQRS. So P, Q, R, and S. And do this in another color. They give letters to the pointed tangency. So that's a W, X, Y, and Z. And they give you some numbers. They tell you that from Q to X is 1.4. XR is 2.7. ZS is 3.1. PZ is 4.2. And I think that's all. Now they give you one. Yeah, that's it. That's all they give you. What you have to do is find the perimeter of that quadrilateral. Find the perimeter. Of quadrilateral PQRS. PQRS. All right. I'll tell you what, it took me a lot longer to draw this thing than it does to actually solve the problem. I promise. All right, so what do we do? We got to find all the lengths of all four of these sides. Well, can I find the length of QR? How do I find that? Add them up. So what's that? 4.1? Is that right? Yep. So that's a 4.1, I think. What about RS? I don't know. I don't know any of these segments. But what did we just learn? we're going to learn that 2.7, this XR, is going to equal this YR, isn't it? So if that's 2.7, what's this? It's 2.7. Remember? From that point, that exterior point to the point of tangency are equal to each other. So those are equal. What about these two right here? They're equal. So what's YS? That's 3.1. And then keep going. What's PW? Say it. 4.2. You guys whisper. Okay, and what about QW? 1.4. Right? So what do you do to all those? Just add them all up. Okay? You know what would be easier than doing what I was just doing? Might be easier to do this. 1.4 plus 1.4, you could just go 2 times what? 1.4. Would you agree? All right, however you want to do it, it's fine. And then you could, let's go around the circle this way. So 2.7, what do you do? 2 times 2.7 plus, what about this? 2 times 3.1 plus these two. 2 times 4.2. All right? So can you double those? What's that? 2.8 plus 5.4. Did I do the math right? Plus 6.2. Oops. 6.2 plus 8.4. Add them all up, and I believe you get 22.8. These are all in centimeters. I didn't do that. Everything's in centimeters. So what's my answer in? It's just centimeter. Is it centimeters squared? No, because it's not area. Okay, it's just the length, the distance around the whole thing. It's just in centimeters, and that is your answer. Again, what was the only geometry that you really did here? Well, perimeter, I guess. You had to know to add them all up. It was to find these missing ones that they didn't tell you. Okay? And remember, these two are equal, these two are equal, these two, and these two. All right? That was the geometry. That was your tangent geometry that we learned. It's pretty easy, isn't it? Yeah. All right. Everybody good with that? Ready to move on? Everybody write it all down? All right, here's a phrase. Let's make this a lot smaller. And let's make another one. Make that just, it could be the same size, but I'm going to make it a little bit smaller just to make it a little different. Oops. Oh, goodness. Come on. There we go. And let's put it right here. All right, I got these two circles. They could be the same size. It doesn't make any difference. But what I'm going to do is I'm going to find their common tangents. So what I want to do is I want to draw a tangent that's tangent to both of the circles at the same time. Okay? So how in the world would I do that? Well, let's start here and see if I can do this. I might have to move one. Oh, that's actually worked out pretty good. Let's just extend this out a little bit. Would you agree that that's a common tangent? Why is it a common tangent? Because it's tangent to what? To both of them, excuse me. How many common tangents do you think there are going to be altogether? 2. Which would? 4. Okay, let's do another one. I'll keep this one in the same color. Is 2 points 1? Yeah. I don't know. Well, it's got to hit. It's got to be tangent to this, and it's got to be tangent to that. So that's 2 points. So that green line is a tangent. It's not the points. Okay, it's the line itself. So that's 1 tangent right there. 3. I heard 2. I heard 3. Do I hear anything else? 4. Sometimes you got to manipulate this a little bit to make it work. There you go. Do you agree? Let's make it actually hit it. It doesn't look like it's quite hitting it. Ooh, good question. Can you go in between? What do the other people say? Absolutely, you could. As long as they hit both circles, right? Is at one point on each circle. Absolutely, it doesn't matter how they go, as long as. So let's do it. So you want to hit this and this? All right. 6? All right. Let's see. There. Again, you got to manipulate it a little bit. If you had a ruler, it'd make it really easy, right? You could kind of get it to hit both of the circles like that. All right. So there's 3. Would you agree? Is there another one? Unlimited? And let's get that to hit here. And let's get that to hit here. All right, that looks pretty close. This one's off just a tad. There we go. Man, need a cough drop. Right there. Check that out. Can you draw any others? Let's go a different color. There's real. How can you? Like if it hits this one, where else is it going to hit here? Like if it hits this circle right here. Right. That's, you can't have any more. That's it. Okay, there's no more. So how many common tangents can you have? 4. All right. So that's all we're talking about right now are these common tangents. We're going to talk a little bit later about common tangents. We're just laying the groundwork right now, just showing you what a common tangent is. All right. And there you go. Let's talk about, this is the last thing. Let's talk about circles being tangent to each other. So what do you think that means? There you go. You got it. A circle touching another circle at exactly what? 1 point. So they don't have to be different sizes. I'm just making them different sizes. But look, if this circle right here was tangent to this other circle, look, I mean, you could draw it all kinds of different ways. I'm just going to draw it right here. Watch. Bam. There they are. They only hit at that 1 point right there. So what do we say about these circles? They are what? They are tangent circles. This right here we call externally tangent. Externally tangent. Why? Because both of the circles are outside each other, okay? And you could actually draw a line that's tangent to both of these circles, couldn't you? Watch this. Cool. What did I do right there? Yeah, that's good. Watch. Well, this would just be tangent to both of them. I guess you could call it a common tangent. I don't know if they do here or not. They just call them tangent circles. Yeah. I guess you could. Everybody see that? So the circles are tangent to each other, and that line right there is tangent to both of the circles. So where is that line going to hit? It's going to hit at the point of tangency. Very good. So you're doing so much better in your new seat. All right. So those are externally tangent. What would it look like if it was internally tangent? Because you got external, you figure there's got to be an internal, right? That's right, the little circle's inside the big circle. I mean, you could put it up here if you wanted, couldn't you? You could put it here. You could put it anywhere around here like this. Okay, I'm going to put it right there. Is that all right? Look, see that point right there? That's where they touch each other. And again, if I zoomed up, you might look at it and you're like, oh, it looks like there's a lot of places they touch. But remember, a circle doesn't have any width. This picture has got some width, so it's going to look like it touches at more than one place, but it doesn't. So this would be internally tangent. That's right. So let's write that. Internally tangent. We good? And we could draw the line that is tangent, and you can only draw one line. There's only one line that exists that's tangent, and I'm going to have to manipulate it a little bit. Maybe make it more about like this. Do you agree? Maybe something like that. All depends where the circle's located on the angle of that tangent line. But that red line would be tangent to both of those circles as well. Okay? So you got circles that are tangent to each other, all right? Or tangent circles. That's what this little section is. I think it is. Let me double check. Tangent, it's supposed to be an E. Tangent circles. Okay, so circles that are tangent to each other are circles that intersect just at one point. What about this? Is that a tangent circle? No, because it hits at 2 points. Okay, so that is not tangent. Yeah, I don't know if they actually call it a secant circle or not. It sounds kind of cool, secant circle, but I don't think they do. Yeah, that's all I've got. So here's your homework. Man, that's like the quickest lesson I've done in a long time, isn't it? Section 8.2, numbers 6 through 10, and 25 to... I think I might have changed that up a little bit. Let me double check. I did change it. This is what I have written on my notes, but I changed it last night when I did the lesson plans. It's 1 through 10 and 25 to 29. All right, and it's pages 355 and 356. There it is, right there. There's your homework.
We're having out a couple minutes early so I can go to the restroom. Your whole lesson.